Welcome back to JVM Internals Crashcasts. I'm your host Sheila, and today we're diving into an exciting new chapter, JVM Internals. We're kicking things off with a deep dive into bytecode and the JVM instruction set. Joining me as always is our JVM expert, Victor. Victor, are you ready to demystify some bytecode for our listeners?
Absolutely, Sheila. I'm excited to explore this foundational aspect of how the JVM works. Before we start, I'd like to remind our listeners that to get the most out of this episode, it's helpful to have a basic understanding of Java programming and general computer science concepts.
Great point, Victor. Now, let's outline what we'll be covering today. We'll start with an introduction to bytecode, explore the JVM instruction set, look at some common bytecode instructions, discuss the relationship between Java source code and bytecode, touch on bytecode verification, and finally, introduce some tools for bytecode analysis. But before we dive in, I've got a quiz question for our listeners. Are you ready?
I'm all ears, Sheila. Let's hear it.
All right, here's the question. In Java bytecode, what does the mnemonic iload0 do? Don't worry if you don't know the answer right away. We'll reveal it at the end of the episode.
Ooh, that's an interesting question, Sheila. It's a great way to get our listeners thinking about the low-level operations that happen in the JVM. Without giving away the answer, I can say that this instruction is something you'll see quite frequently in bytecode, and understanding it can give you insights into how Java manages variables at a low level.
Thanks for that insight, Victor. Now, let's start with the basics. What exactly is bytecode?
Great question, Sheila. Bytecode is an intermediate representation of Java code that's generated when you compile a Java source file. It's not machine code that can be directly executed by a CPU, but rather a set of instructions that the Java virtual machine can interpret and execute. Think of it as a bridge between human-readable Java code and the machine code that actually runs on your computer.
That's interesting. So it's like a middle ground between source code and machine code. Can you give us an analogy to help understand this concept better?
Certainly. Think of bytecode as sheet music for a player piano. The Java source code is like a composer writing a musical piece. The bytecode is the sheet music with perforations that the player piano can read. The JVM is like the player piano itself, interpreting the perforations, or bytecode, to produce the actual music, which is our program execution.
That's a great analogy, Victor. Now, you mentioned the JVM instruction set. Can you tell us more about that?
Of course, the JVM instruction set is the collection of operations that the Java virtual machine can perform. These instructions, often called opcodes, are the building blocks of bytecode. They include operations for loading and storing data, performing arithmetic, controlling program flow, and more. Each instruction is represented by a single byte, hence the term bytecode.
I see. Can you give us an example of a simple bytecode instruction?
Sure thing. Let's take the iconst1 instruction. This instruction pushes the integer constant 1 onto what we call the operand stack, which is essentially a temporary storage area for values that the JVM is working with. It's a very simple operation, but it's used frequently in bytecode.
That makes sense. Now, how does this relate to the Java source code we write?
Well, when you compile Java source code, the compiler translates your high-level Java statements into sequences of these bytecode instructions. For example, a simple Java statement like int x ifrav1 might be translated into bytecode that includes the iconst1 instruction we just discussed, followed by an instruction to store that value in a local variable.
I'm starting to see how it all fits together. But, Victor, I've heard that bytecode is verified by the JVM. What's that all about?
Excellent question, Sheila. Bytecode verification is a crucial security feature of the JVM. Before executing any bytecode, the JVM performs several checks to ensure the code is valid and safe to run. This includes checking for type safety, ensuring stack operations are valid, and verifying that jump instructions lead to valid locations in the code. It's like a bouncer at a club, making sure only well-behaved code gets in.
That's a fun way to think about it. Now, I'm curious about how developers can actually look at and analyze bytecode. Are there tools for that?
Absolutely. There are several tools available for bytecode analysis. One of the most commonly used is JVM, which comes with the JDK. It's a disassembler that can show you the bytecode instructions for a compiled Java class. For more advanced analysis, there are tools like ASM and ByteBuddy, which allow you to manipulate bytecode directly.
Fascinating. It sounds like understanding bytecode can be really powerful for Java developers. Are there any common misunderstandings about bytecode that we should address?
One common misconception is that bytecode is slow because it's interpreted. While it's true that bytecode is initially interpreted, the JVM uses something called just-in-time compilation, or JIT for short. This process converts frequently executed bytecode into native machine code, which can run as fast as compiled C or C++ code in many cases.
That's a great point, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. The question was, in Java bytecode, what does the mnemonic iload0 do?
Yes, the quiz question. The iload0 instruction loads an integer value from the first local variable, which we refer to as index 0, onto the operand stack. It's a common operation you'll see at the beginning of many method calls, often used to load the this reference in instance methods.
Thank you, Victor. That's been an enlightening discussion about bytecode and the JVM instruction set. To summarize the main points. 1. Bytecode is an intermediate representation between Java source code and machine code. 2. The JVM instruction set consists of opcodes that perform basic operations. 3. Java source code is compiled into sequences of bytecode instructions. 4. Bytecode is verified by the JVM for safety before execution. 5. Tools like JVM allow developers to analyze and understand bytecode. In our next episode, we'll be diving into method invocation and return mechanisms in the JVM. Don't forget to subscribe to JVM Internals Crashcasts and leave us a rating if you enjoyed this episode. Until next time, keep coding and stay curious.